Hello, everyone. Today is the third part of the deep learning. We did the deep learning using R scripting, deep learning using Python, and today we'll look at deep learning in TensorFlow, which is very handy and very efficient that I want to experience today. Let's start with this is general the steps that you guys need to do in order to do the deep learning, particularly if you want to train neural network and test it. Then we need to read data. Read the data and put it in data frame. And of course, we need to normalize if we want. Better to normalizations. And then we need to split training data sets and test data sets from the given data sets. Excuse me. And then we need to do neural network. And then finally test and evaluations. While you are doing, we are setting up and training in neural network, we may need to consider the activation function. On this slide, displays multiple of different activation functions, right? When it comes to this, then it goes these values. If this over that, then it turns out to be 1 all the time, right? This is more stiff, and this is more linear, others as well. So sometimes we use this ReLU, or sometimes we use a sigmoid. The way that we want to splitting the data sets, given data sets, if we are working on Python, then Python has a very, very useful function that we want to use. So it returns 4 types of data sets. Xtrain covers this much, and Ytrain covers that the target column data, and Xtest is the data sets for testing. Of course, there is no the target columns. Only the target columns for this Xtest is called the Ytest. This is real actual data, and from your neural network, which is well trained, then this Xtest, each row in this Xtest may fall in some of the values, some of the predictions. So we need to compare this prediction from here and the actual data that we split, that we dropped from this test data sets. So TensorFlow is a machine learning platform that can do data automation, model tracking, and retaining. Basically, in this tutorial, we'll look at model training. If we go for, TensorFlow requires lots of the computing power would be great if you have a GPU, and and the installation of TensorFlow needs some special care. So if you do not want to go that hassle procedures, then and also in this tutorial we are going to use Google products, which is a Colab. Okay, so we're going to look at the Colab. This is the logo of a Colab. If we go with the Colab from Google, this is the web-based, then GPU is not required because the Google server provides you. If you do not have sufficient computing power, still okay as far as you can open up a web browser. So this is really, really handy. Basic tutorial for the TensorFlow working on Colab. Then this is not necessarily Colab, but in general, but it works very nicely in Colab. We have to import TensorFlow, Panda, NumPy. This particular slide for NumPy, if you want to generate input data, should be input, not. All right, let me change this. Input. All right. Oops, again. And let's assume this is an input, and for each data, we say this is a label, like a churn, the column to churn, column to determine 1 or 0. Given 0, that is 1, 1, that is 0, 2, that is 1, 3, that is 0, things like that. Let's assume that. So we can make a data set using data set from tensor slices. Or we can read data from some of the files like this. If we import the pandas, then panda PD has the function readCSV, so that we can read it, and then we can do further. Okay, so basically TensorFlow is written in Python, so you need to if you understand the Python, then this is a little bit extension from Python. To build a neural network on Python, on TensorFlow, then we have basically two APIs available: Sequential API and Functional APIs. Functional APIs, that is for a little more complex data models. So we're going to use a simple data model in this tutorial. So sequential API model is sufficient. To do that, we need to go this colab.research.google.com. If you click this, then you can have something here. I have some already, but we want to have a new notebook. So let's click new notebook here, or you can go here, file and new notebook. Anyway, if you start from scratch from the beginning, then anyway that is a new notebook, and there is no file name for this. So in this case, my cars, my nn, my neural net cars. You can start like this. As you might already understand, then we have input nodes and output nodes, and then there's a hidden nodes. So having that said, so this is same as before. We can, if you want to work on sequential, then model is a sequential, and then you can add the layer dance of layers. The initially input data is 10, activation ReLU or sigmoid, and this is for this layer, for the 10, right? And then you can do, input is 10, and from input to this layer is a connection. There is a the network, right? From input to input to that node, the hidden layer, from 10 nodes to 32 nodes. That is this. Input shape is 10, it goes to 32. And then you can add more layer all the way back to the output node too. If you have more, then you need to have more addition, right? In other words, if you have input and then if you have other two layers of hidden sector, in this case only one layer, right? But if you have more, then you could have more layer here. You need to add more. That is the same as this. You can do separately each one of those, or you can simply sequential, and then you can define them all instead of saying add. All right. This is a sequential API mode. If you have functional API mode, a little more complicated cases, then you need to use like this. But in this tutorial, we simply use the simple ones. So this is a car, as you might know. So the way that we read from this CSV files, then this CSV file is supposed to plug it in your if you put here, then there is a it is called drive. So there is a Google Drive. So you need to have a Google Drive. So if you go to Google Drive, then I believe I have let's say, my drive. If you go to my drive, then you can create your drive. I call it TensorFlow datasets, like a folder. Okay, you can make call here, and then new folder, click new folder, and then you call name, and within this, then you need to bring those two CSV files. I posted these two CSV files on the Blackboard, so you can download it on your local drive, and then you can post it on your Google Drive. All right, so once you have that, then you can look up here, Google Drive, mount to drive. You need to first mount it. So connect to Google Drive. So you have a drive. You unfold this, and then unfold, then my drive. Then you need to find out the folder that you just created. I said the TensorFlow dataset in my case, and click it. Then I have two CSV files. If I want to play with the cars.csv files first, then on the right end there is a three dots vertically. Click on that, and then you can copy path. So we can use this path. Okay. We need to first import Panda as PD, and then from sklearn model selection, we need to import train test. This is the same as the one that we looked at simple the Python based neural network, right? So path is the path that we just copied. So I paste it back here. There's the CSV files. And then I want to read the CSV files. Path, and I want to send it to my local variable df. And then data sets is nothing but df dot values. So if we want to see data sets, we may do like this. If you want to run this, then there is a button. So click on that. Then very nicely it reads, right? 28.0, 23.0, 40.99, 620. That is the first row. And this is in the middle, we omit, and then this gives us all of those. So data is on our TensorFlow right now. And then we need to make data drop sales, right? We could do the way that in Python, but here very nicely it says get dummies. So we can say get dummies, and then df dot drop. We have drop. So drop what? So we want to drop, let's say, sales, because sales is our target. Okay. And then x is equal to 1, and then y equals df and simply sales. This is something that we had, remember the splits x, that is training data sets, training data, we didn't split yet training data sets and test data sets. We simply identify which one is our target, which columns are not. So these columns are not, this is target columns at this point. And then we need to do xtrain and xtest and ytrain and ytest. That comes from train, test, and split when we enter x and y, and then test size is, I would say, 95% for training and 5% for test. If you want to that, then that is that. And then xtrain, make sure that if we have xtrain, what is ahead? First few lines of code. And then ytrain, this is only training. So xtrain, that is the main part. Y means that is only for sales portion, so targets, right? So up to this point, if you want to run it, then you can see I believe this is let's say we don't print this. Yeah, this comes from xtrain, and I think this sales that come from here, because we are saying only head. But if you want to see data themselves, okay, simply another beauty here on this the code lab, this is a part of the code segment, but if you click this, then that is another segment, so that you can say here xtrain, xtrain. I want to see xtrain. Then if you click this, then this gives you xtrain, right? And then another code here, if you want to see ytrain, and then click, then that is ytrain. Only this y portion. There's everything about age, to income, but there is no sales, which is the target. But in this case, only the target case. Column wise, it picked randomly, right? It's not the way that we split in another languages. If we use this, then we can test it very, this guy tells us automatically which one is what. Okay, so once we have this, then we need to import say from TensorFlow.class.models, and then we can import sequential and load model, and again from TensorFlow.class.layers, we want to import dense. From sklearn and matrix to evaluate, and then we can do import accuracy score. Now we can build the models. Okay, we can models. So model is sequential, and to that model we need to do add and dense units equals let's say 4 input nodes, and activation function may be RELU, and then input underscore dimension. Input dimension is length of X train columns. Yeah. So we need to add another layer of dense. Of course, this is hidden. And units, we can increase whatever the number, right? So 4, 16, and activation function, let's say still RELU. And then we can add more dense, and then unit finally outputs equals 1, and activation equals let's say sigmoid. So if you want to see model, so it tells us the summary of these sequential models. We have layers, 3 layers, starting from 4 and 16 and 1. Total parameters 121, but this is only we set up the models, and then we need to compile the models. So compile the models. Model dot compile. When you do compile, then we use loss function and optimization and matrices. Loss function maybe binary cross entropy. You simply use it. Right now, it has a lot of theory, so don't worry about it. So loss and optimizer. Optimizer is you can use Adams or SGD. Let's try do SGD, and the matrix and matrix equals accuracy. So this is a compile the models. So let's see if it compiles the models. Yeah, there's no errors. And then we need to train. So fit, right? So model.fit xtrain and ytrain. So xtrain actually what it does is okay. So we have xtrain and ytrain. This is the data sets. This is the label or targets. So we train this kind of record, then we train, hey, that is this number. Another kind of a record, then that is this number. What that means is that if we have this kind of data sets, then sales price is 620. This kind of data sets and sales price is 27,754. Of course, this kind of the target columns is not really good target columns, because with these values, it's not really good value to churn, to determine. It's really good values if you have a 0, 1, or some limited numbers, some distinct number, right? 1, 2, 3, 4, 5. So we have 5 categories. So each record may fall in one of those 5 categories. That type of columns is really good columns. The reason that we first work on this specific the example, the data, is we need to compare this and with the others. The other one, dividend info.csv files, that has the column, the target column, which can churn the patterns very nicely. Okay, so after this, then we'll look at that also. Okay, so we train that xtrain and ytrain, epoch, which means how many times that we want to run this, and then batch size, BATCH. Batch size is about 32. So at one iteration, it takes 32 records at a time. And then we can do predict. Then Y predictions can come from model.predict and xtest. Xtest is predicted, right? And then we can simplify a little more and y predict simple is some of the codings. If value is less than 5, then we say that is 0, otherwise 1 for other values, for val in y predict, something like that. Okay. Zero if that as what this guy has some errors, so we don't need to simply predict. And let's try it. So it goes 500. Okay, it stopped, right? So it iterated that many times. And then we can do evaluation. Go to eval equals, we need to do eval. Evaluation. Eval equals accuracy score. The y test is actual test, actual value, and then y predict is predicted by this neural network. And then we can say print and then you can say eval. Okay. So there is an error. Some of the no values, so we better do it's like this. As we tried to do previously, so we can do this, and we can do predict and run it. So evaluation for this is not really good, right? It should be if it is 1, 0, 1, then that is a perfect learning. 0 means it is no good, right? But anyway, that is because of these characteristics. So if we change this to, for example, this dividend, then let's go to here. I'm not going to redo this, simply change this. So that is dividend. And let's say our target is dividend. So we simply say here dividend, and copy this. And others may be the same, right? Simply we can rerun this. Then in this case, it's not anymore cars, but we say that is dividend. Okay, and I am going to run this. Evaluation is a little better, 0.2, right? 0.22. What if we do, for example, not 500 time iteration, but let's say 5,500. Big iteration. See what happens. I know it takes a longer time. But I will stop. If this runs, this gives us a better evaluation, then I'll stop it. You can play with this. In other words, you can add more inside of this, so more hidden steps. This unit, you can change this also, multiple others, like we changed this, right? Then you may have different performance of your neural network. Look at this, the loss and accuracy. It's very hard to change, right? So accuracy needs to go up and loss needs to go down. Depending upon the iteration, we may have different performance. So it needs a lot of iterations. That is the reason GPU is needed. This neural network or deep learning. only 40% done. Almost done. Evaluation still 0.22, not much improved. But anyway, so you can do like this. Let's say I want to do one more time, only 1,000 times of epoch. Let's say this say 8 and then 32. I'm going to increase a little more and see what happens. Oh, 50% of the evaluation, which is much better, right? Yeah, something like this. yeah, this is how you can run or set up a neural network on the TensorFlow. I'm using the TensorFlow on the platform of Colab, which is provided by Google. All right. Thank you.